Hello friends, welcome to Engineering Mechanics lecture series. Today we are going to see the topic supports and reactions. So before going into supports and reactions, we should know certain basic concepts. The first thing is beam. So what do you mean by a beam? So beam is nothing but a horizontal member which carries load perpendicular to its axis and transfers the load to the supporting walls or columns. So beam is a horizontal member which carries load perpendicular to its axis and transfers the load to the supporting walls or columns. So you can see the beams in all the constructions, in houses, in shopping malls, in every complexes. So beam is a very essential member. Then a frame. So what do you mean by a frame? A frame is nothing but it is a structure made up of several members which are riveted or welded together. So you can see in a window, a steel frame has been fixed in a window. So all the several members are joined by means of either welding or riveting. So such is called as a frame. So what do you mean by a support reaction? So support reaction is nothing but the force of resistance exerted by the support on the beam. The force of reaction exerted by the support on the beam is called as support reactions. So a force which offers resistance to the beam, and that is called as a support reaction. So now the types of supports. What are the types of supports that are available? Roller support, hinged support and fixed support. These are the three major supports that are available. So what do you mean by a roller support? So roller support is the basic support. So the roller support may have a single roller or a group of rollers. So this support can prevent the displacement of the beam only in the vertical direction, or only in the direction in which it is placed. So here a single roller and group of roller are supporting the beam in the vertical direction. So it offers resistance to the beam, it offers resistance to the displacement of the beam in the vertical direction, but it cannot offer resistance to the beam when a force is applied in the horizontal direction. So there is only one reaction offered by this roller support. The reaction depends upon the position which the support is given to the beam. If it is a vertical roller, then the reaction will be in the vertical direction. If it is a horizontal roller, the reaction will be in a horizontal direction, or if the roller is inclined, then it will be perpendicular to the axis of that inclination. So the support reaction by the roller is always normal to the plane in which the roller is acting. So this is about a roller support. So I have given here three types of roller supports: single roller support, a group of roller support, and a support roller acting in the horizontal direction to the beam. So in each case the reaction is always normal to the plane. So the next support we are going to see is the hinged support. Hinged support can withstand both horizontal and vertical forces. So you can see this hinged support. The practical example is all the doors are fixed to the frame using a hinged support. So the door cannot move in the horizontal as well as in the vertical direction. So hinged support offers resistance to the horizontal and vertical movements of the beam, and also it offers two reactions, horizontal reaction as well as the vertical reaction. We can see hinged support is represented here. So this is the point A in which the support is hinged, it acts on the beam. So it offers two reactions, one is the horizontal reaction, another one is the vertical reaction. So previously we have seen the roller support. So both roller as well as hinged support can resist only the displacements. Both roller and hinged supports can resist only the displacements. The next support we are going to see is the fixed support. So now this fixed support can resist the rotation of the beam in addition to the displacement. It can resist the rotation of the beam in addition to the displacement. So if a beam is completely fixed, suppose if this is the beam and this is the support, and if the beam is fixed here, then it cannot move in the horizontal as well as vertical, or it cannot rotate since it is fixed here. So a fixed support offers three reaction components. One is a vertical reaction component, another one is a horizontal reaction component, and third one is the rotational reaction component. So all these three components makes the beam a fixed one, and the beam cannot move or rotate. So that is the condition of a fixed support. So we have seen three supports today. One is a roller support, another one is a hinged support, the third one is a fixed support. So roller support offers only one reaction normal to the plane. Hinged support offers two reactions, one is a vertical, another one is horizontal. So the hinged support resists the displacement of the beam, and it does not offer resistance to the rotation of the beam. Whereas a fixed support has three reaction components: a vertical reaction, a horizontal reaction, and a rotational reaction. So this prevents the beam from displacement as well as from the rotation. Next we will see the types of loadings. So there are again three types of loadings are possible. One is a point load, second one is uniformly distributed load, which is known as UDL. Another one is uniformly varying load, which is known as UVL. Now the point load is represented here. So there is a beam AB. One end of the beam is supported with hinged support, and the other end of the beam is provided with roller support. So the hinged support offers two reactions. One is a vertical reaction, another one is horizontal reaction. And the roller support offers one reaction, that is normal to the plane. Now there is a load acting at a point on the beam. A load acting at the point of the beam, because compared to the size of the beam, the area of contact of the load on the beam is very small. Compared to the size of the beam, the area of the contact of the load with the beam is very small. That is why it is called as a point load. That is why it is called as point load. Next is called as UDL, uniformly distributed load. Now we consider a beam AB of length L. Now a rectangular wall of uniform dimensions is placed on the beam. So this is a rectangular wall of weight W. It is uniformly distributed throughout the beam. Now uniformly distributed load means for each area of the beam, the intensity of the load will be distributed uniformly. For each area of the beam, the intensity of the load will be uniformly distributed. Now this is represented here. This is a uniformly distributed load. So W kilonewton per meter. Suppose if it is an 8 kilonewton load, this 8 kilonewton load will be acting on the center of the beam. It will be acting at the center of the. The next load we are going to see is called as uniformly varying load. So I consider a beam on which a triangular wall is constructed on the beam. So you can see that at the point A of the beam, the load is 0 and it is gradually increased from A to B. So the weight of the wall at point A is equal to 0 and it is gradually increased from A to B, and this is shown in this figure. Now the rate of loading on each unit length of the beam varies uniformly. You can see that the rate of loading on each unit length of the beam varies uniformly. That is why it is called as uniformly varying load. So the total load on the beam is equal to area of the load diagram, and it acts on the center of gravity of the load diagram. So I will once again explain it. So the weight of the wall at point A is 0. The load is gradually increased from A to B and reaches maximum at B. So the rate of loading on each unit length of the beam varies uniformly. That is why it is called as uniformly varying load. And the total load on the beam is equal to area of the load diagram, and it acts on the center of gravity of the load diagram. Center of gravity of the load diagram. So in today's lecture, we have seen about supports and reactions. We have seen about the types of supports. Then we have seen the types of loads. The next lecture, we will solve problems based on supports and reactions. For more interesting lectures on engineering mechanics, please watch this video and share and subscribe.